What on earth is abstraction? That's what we look at in PIC Computer Science video number 24. Abstraction is part of something called computational thinking. And how I like to term computational thinking is how do we think our way around a problem so that it can be solved with the help of a computer. The phrase computational thinking was actually coined by this gentleman, Seymour Papert. We see him covered in Lego, and he invented this phrase in 1996. And things he might say about it are that it is a problem-solving approach. It borrows techniques from computer science, such as abstraction, and techniques we'll look at in future videos, such as decomposition and algorithms. Computational thinking can be applied to a wide variety of problems, and not just the development of computer systems, and we'll see a little bit of this later on. If we look up the word abstraction in a dictionary, such as dictionary.com, we'll see there are lots of meanings to that word, and where we might have come across the word before might be in things like number 7 there. Within the arts, you might be familiar with abstract works of art, certain sorts of painting. There are other meanings, but the one that we're probably most interested in is number 4, the act of taking away or separating, withdrawal. So let's think about that idea a little bit more. Thinking about abstraction meaning taking away, we might be familiar with the term as in abstracting a tooth, or the abstraction of a tooth, which you'd hopefully want to get done by a qualified dentist rather than using some pliers yourself. And even abstract art itself, as per this example, has things taken away from it. There's a certain lack of detail in this picture, but it's supposed to symbolize and signify something. All computer systems are abstractions. For example, a database that stores details of students is an abstraction of the real students. So colleges, schools will store lots of pieces of data and pieces of information about students, but it certainly wouldn't store everything about them. Only the things that are relevant to the college or the school. A really classic example of an abstraction is the map, whether that be a paper-based map or a map on a computer, such as this software here, Memory Map. Here we've got a section of the north of England, and that is an abstraction. On this map there isn't detail about everything in the north of England. Even if we zoom in, we start to get to particular places, we can actually see place names and maybe a few lines, a few roads, a few hills, but we certainly don't get to see all of the detail. Even if we were to scale in, so we increase the detail in the map, so this is 1 to 50,000 ratio, we start to see streams and buildings, or some buildings, and we start to see contours on hills, but again, even where there are trees, we're not showing every tree, we're only showing, we're only symbolizing that there are trees there. Even if we go into the largest scale, so 1 to 25,000, so this is the most detailed ordnance survey map, we now get to see probably all buildings, we get to see all field boundaries, all footpaths, we get to see all contours on hills. We still aren't seeing every tree, and this is still an abstraction. We've still taken out a lot of the detail. If we have a map that had every single tree, every single pebble, whatever, every single person, it would be too much detail, and the map would become useless. So abstraction is required even in something like a map. We can, with Memory Map and with things like Google Earth, actually go to an image view of a map, which does, I guess, show the sort of detail where there is less abstraction, because we are now showing every tree, every large rock, even every little blade of grass, even if the human eye can't make it out. But computer scientists might argue that we still have an abstraction here. This isn't the real world, it's just an image of it, and we're getting into the quite deep thinking behind abstraction there, but it's something to think about. Even a paper-based map from hundreds of years ago, like this one, involves abstraction. There's certainly not every little bit of detail as in reality, as in real life, shown on this map. So it just goes to prove that abstraction can be a concept that is used and put into practice even without computer systems. Another classic example of an abstraction would be a simulator, such as this flight simulator, which is used to often train pilots. Whilst all of the controls might be the same as what you might find in a real-life reality aircraft, and a lot of the detail on the computer-generated imagery might be looking like it is real life. We know it's only images, so we could consider that to be abstract. Plus, are we getting the full effect, the real effect of a real flight? Are we getting the G-force? Are we getting the turbulence? Are we getting the danger that is involved in reality with a simulation? So, simulations can often be also considered as abstract. Key terms for your exam to do with abstraction. Things that you would want to write down if you've got a question to try and describe it, define it. A process of separating ideas from particular instances or reality. Separating ideas from reality. A means of hiding detail. Only using relevant detail. A representation of reality, often using symbols or text to show real-life features. Irrelevant features are left out. You're also very likely to be asked why we use abstraction, and you'd want to be saying these key points. Reality contains things that aren't relevant to a computer program. These would require unnecessary design effort, unnecessary programming effort. They would require extra computational resources, and, I think this is also key, they would detract from the main purpose of a program. If we tried to build a computer system that exactly matched a human being, rather than just giving a few details like it's the human's name, address, date of birth, etc., then we'd be trying to recreate the human, every little molecule, every little atom that was inside our bodies, and is that what we want to achieve, or do we just want basic information about a human? Often with computer systems, less is more. Less information is actually more meaningful, more useful. So I think that's what that last point on that slide is getting at. Another thing you might get asked to do in an exam is to create an abstract model. So given a scenario, and maybe given some data, to create an abstraction of a real-life situation, such as a map, for example, and talk about things that would be included maybe in a map and things that might be left out. Hope you enjoyed that abstract video. Thanks, bye.